Welcome to the IoT channel and to the fourth video in a series in which I share my journey of setting up a Domoticz home automation system. And in this fourth episode, we will configure a Wi-Fi sensor alarm connected to Domoticz. I want to thank Andreas Spies for having done the heavy lifting in this project. Again, I find myself on the shoulders of giants when embarking on this fabulous journey. The goal of this project is to create a sensor which I can hang at the front door. Whenever a device with an unknown MAC address is near the sensor, I'm notified of this by a light switching on or receiving a telegram message. Let's go through each of the steps of the process. It all starts with an ESP8266 polling for MAC addresses, and after composing a list of these MAC addresses, they are published onto an MQTT server. Node-red is subscribed to these MQTT messages, and it picks the messages up and compares the MAC addresses to a list of known MAC addresses. When an unknown MAC address is spotted in the list, Node-red formulates a command for Domoticz to turn a dummy switch on and posts that command on MQTT. Domoticz picks up the command and turns the dummy switch on. An event in Domoticz is triggered by the switch being turned on and sends a message to Telegram. For this process to work, we need to tie some technologies together, which will make this a lengthy video. But in this video, I hope to give you a glimpse of each of these technologies, which may inspire you to use them in your future projects. In this video, I will give a brief explanation of what Mosquitto and Node-red are. We will set up each of the required components in the process and finally tie everything together. So what are Mosquitto and Node-red? In short, Mosquitto is just Twitter for machines. For example, Jill posts jokes on Twitter daily. She is a publisher. And John, he likes a laugh and is subscribed to them. He is a subscriber. When Jill puts a new joke on Twitter, every subscriber to the topic receives that message. MQTT is nothing more than a message broker, just like Twitter is, but then for machines. Today, we will use an ESP8266, which will publish messages with a certain topic onto the MQTT server. Node-red is subscribed to this topic and picks up these messages to process them. Mosquitto is an open source MQTT server which we will use in this project to accomplish the task. Now, what is Node-red? Node-red helps you to wire together processes in a user-friendly way by using nodes. And there are three types of nodes. Input nodes will listen to new events happening. For example, a file or folder change, a message with a topic being posted on MQTT, or a new mail arriving in a mailbox. The second type of node is a process node, which will alter the incoming message, sorting it, for example, or splitting it, or you can even create advanced processing of the message through a JavaScript function node. And then there are the output nodes, where the output is sent somewhere. A mail can be sent, or an HTTP GET or POST request can be invoked, or a message can be put onto an MQTT server. Nodes can be linked together in a flow. Think of it as an assembly line where a message comes in at the first node and is pushed from node to node where it is processed, altered, enriched, replaced, tested, rejected, split, and when desired, pushed to an output. The node types that are shipped by default are not the only ones you can use. You can add nodes to the palette by installing them. Whether you want to send instructions to a Sonos system, or if you are the owner of a Tesla and you wish to control it using Node-red, whether you want to connect to an SQL or a MySQL or a MariaDB database to read, write, update records, or if you want to connect to smart devices such as Philips Hue to control the lighting from Node-red. These and many more node types are one click away. When you have created a flow, you can port it to another Node-red instance by selecting the nodes, and in the hamburger menu you choose Export. You select the code and copy it to the clipboard, or you save it. And on the other Node-red instance, simply import the flow or the selected nodes by choosing Import and pasting the code. To install this wonderful software, we can make use of the point-and-click installation wizard which Dietpi offers. Let's see how to install it and test the installation afterwards. Let's first install Node-red and Mosquitto on our Domoticz server. And for this, in Windows, you would typically use a program like PuTTY to create an SSH connection with the server. But when you're working from Linux, you can just open a terminal window and we can get started from here. So we are going to SSH into the Domoticz server like this. You type yes here and then you type the password. Now I have different options as I'm shown here, and there's Dietpi launcher, config, software, etc. I just launch Dietpi software. And in Dietpi software, I can search for optimized software here. I can either list it or search for it. So I can search for example, Node, which says Node-red, okay. And I can also search for Mosquitto. Mosquitto. With both programs selected, I can click Install below, press OK, and both applications will be installed. Let me fast forward to the moment where I am shown a prompt. And we continue after the reboot. After reboot, you can just log back into the Dietpi server. Because on here, both Mosquitto and Node-red should be installed. Now, you can, of course, change the configuration of both Mosquitto and Node-red. For Mosquitto, you just go to etc Mosquitto, and there you have a file mosquitto.conf. So when I nano it mosquitto.conf, you see that in here it's referenced to /usr/share/doc mosquitto examples, and there's a mosquitto.conf example. So you can complete it there and copy that example to etc mosquitto/conf.d to append it, if you will. So when I Control X out of here, I can go to that folder. Oh, I'm sorry, I added the file as well. I can go to this folder. I can list the files in here, and I see indeed that that conf file is in there, but it is zipped. So first I need to do gzip -d and then the mosquitto conf file. And now it's just a conf file. So I can nano that one. And in here, I have a sample configuration of my Mosquitto server. So you can add passwords in here. You can change the port on which it listens. So in here, you can really manage and change the behavior of Mosquitto. That is not going to be part of this exercise, but certainly if you put Mosquitto on a public server, it's advisable that you secure it somehow. So I will Control X out of here. To change the settings of Node-red, you just go to /usr local lib node modules Node-red. And in there, you will find the settings.js file. When I open it, you will see the entire configuration of Node-red here, and the port on which Node-red listens, and also information about credentials, about usernames and passwords. So here is the chapter on securing Node-red. Again, it's not part of this exercise to harden Node-red, but it is advisable that certainly when your server is on a public-facing server, that you just do that. We can easily test the working of a Mosquitto server, and you do that by installing the Mosquitto clients via the Linux terminal. So when you're working on a Debian or Ubuntu-based machine, you can sudo apt install Mosquitto clients, and it will install the Mosquitto clients for you. And what are those Mosquitto clients? First of all, you have a listener, which is called Mosquitto sub. And Mosquitto sub, when you look at that command, behind it you can say with the -h what the IP addresses of the Mosquitto server you wish to listen to, the topic or topics you want to listen to, and this means that I want to listen to new messages from any topic or with any topic, and I want a verbose output. So I don't only want to see the message, but also the topic. I want to see them appear over here. When I press enter, it starts listening. From my other terminal, I can use Mosquitto Pub. Mosquitto Pub allows you also to connect to that same MQTT server and to publish a message on that MQTT server. And here I'm going to publish a message with the topic test and the message between double quotes, yo yo yo. When I now press enter here, that message will be published on the Mosquitto server, and any client listening to messages with that topic or listening to messages with any topic will receive it. And here you see that the message has arrived at my listener, at my subscriber. To check whether Node-red is working, you just need to go to the IP address of the server where you installed it on, and you just add a :1880, which is the default port where Node-red is listening on. And then you arrive on the Node-red homepage. Node-red is a programming tool for wiring together hardware devices, APIs, and online services in an easy and interesting way. For example, what we can do with Node-red is make it listen to MQTT messages with a certain topic. And when such an MQTT message comes in, we can pass that message through a function node and do some calculations on it, for example, and in the end, for example, spit it out again back on the MQTT server. And this is how easy it is to link together nodes to construct your own applications. Going into details into the inner workings of Node-red is not in scope for this video, but I'll link some videos on YouTube where you can find more background information with regards to Node-red. We will now set up Domoticz to listen for instructions which are published on the MQTT server. In Domoticz, we will add MQTT as hardware by going to Setup Hardware, and we will give this hardware a name and choose MQTT Client Gateway with LAN interface as type. We type in the remote IP address of the MQTT server or localhost when it runs on the same machine as Domoticz, and we enter the port on which MQTT listens. By default, Domoticz subscribes to the topic Domoticz/in, and when publishing messages, it uses Domoticz/out as a topic. Now we will create a Telegram bot and connect it to Domoticz so it can send push notifications when a dummy switch turns on. I presume you already have a Telegram account and the app installed. I'll show you how to set up a Telegram bot and get the token and chat ID to use in the Domoticz configuration. In Telegram, start a chat with Botfather. Send the message /new bot and follow the instructions. After assigning a name and a valid username, you will get the token, which we will need later on. To activate the bot, find it in Telegram and send it a message. Just any message will do. And now we can find the chat ID of the bot by constructing following URL in your web browser. First you type https://api.telegram.org/. Then you enter the word bot, followed by the API key which you generated before. And after that, a /get updates with a capital U. The JSON object shown in the browser contains the chat ID. In this screenshot, it's shown in blue. Then in Domoticz, you can go to Setup, Settings, Notifications, and there you can fill out the API key and chat ID. When pressing the test button next to it, you should receive a Telegram message in your app. Okay, now we have done many things already, and we're almost there. Mosquitto is up and running, and so is Node-red. Domoticz listens for Mosquitto instructions and can send Telegram messages. We now just have to set up the ESP8266 sensor, configure Node-red and Domoticz, and then we're finished. Let's start at the beginning. I bought a cheap ESP8266 from AliExpress or from somewhere else. You can find these in any cheap Chinese webshop. I also installed the Arduino IDE onto my Linux PC, but as you can see, you can also install the Arduino IDE on Windows or on Mac. And now we are ready to start downloading the sketch. From the GitHub project page, we're going to download the code. And the project consists of a folder, Wi-Fi sniffer as a human detector master, and in it there's one directory and a variety of files. The file node-redflow.txt will need it later, not at this moment. At this moment we're only interested in the Wi-Fi sniffer folder, and we're going to extract that one. We are going to save it into the Arduino folder, which is in our home directory. And when that is extracted, we are going to start the Arduino IDE and we are going to open up the Wi-Fi sniffer INO file. When you open that Wi-Fi sniffer INO file, you will see next to it some other tabs that have been opened. The nodes.h, the functions.h, MQTT.h, and the structures.h file. Some things need to be altered in order to make this configuration work. First of all, in the Wi-Fi sniffer INO file, you need to change the credentials, the credentials to access your wireless network. You need to enter the Wi-Fi SSID between those brackets and the password for the Wi-Fi access point as well. The first time I uploaded this code to my ESP8266, I got an error message. This error message, not published. Please add define MQTT packet size 2048 at the beginning of the pub_subclient.h file. If this happens, this error, you need to add this code to your pub_subclient.h file in the libraries folder as a subfolder of the Arduino folder. Don't forget that. On the MQTT tab, you need to add the name of the MQTT server on which you're going to post this all the messages that come from this sensor. Back on the Wi-Fi sniffer tab, when going down towards the end of the code, you will see this section here, the send devices part, where the MQTT server that has been defined on the MQTT.h tab is being used here, and also the port on which it is listening is being shown here. If your MQTT server listens on a different port, you can alter that port information here. Also, if your MQTT server is protected by a username password, these two can be altered here as well. To upload the code, I will first need to choose the correct board, and I do this by going to Tools, Board. I choose ESP8266, and I can choose, for example, a generic ESP8266 module. After this, I can go to Sketch, Upload, to upload the code to the ESP8266. When the upload is complete, the ESP8266 restarts itself, and I can, using the serial monitor, I can now see live what is happening on the ESP8266. I have to select the correct baud rate that I initiated or that was indicated in the document as well, or in the program as well. And now you will see a constant stream of the MAC addresses that were recognized by the ESP8266 and are being published to my MQTT server. To verify that the messages generated by our sniffer actually end up on the MQTT server, we can, from our terminal, use the Mosquitto sub-client to poll and to listen to new messages on our MQTT server. And the syntax is as follows. So Mosquitto underscore sub, then the host name, which is the IP address of the MQTT server, the topic we are going to listen on, and if you look in the code, you will see that the default topic being used is sniffer and verbose output. So when I click enter here, we are now listening to messages landing on the MQTT server with the topic sniffer, and we will see that new messages arrive. You see, and this is the list of the MAC addresses that were recognized in my home. Now, how can we configure Node-red to process the code and post it on the MQTT server again? We again start from the code of Andreas' piece to configure Node-red. And for that, we open the Node-red flow.txt file on the GitHub page of Andreas. We will display his code in raw, so we can easily copy and paste it by selecting all the code, opening Node-red, and opening the hamburger menu, choosing Import, pasting the code, and clicking Import again. And then you will see that the default flow of Andreas is being shown here. First of all, we're going to clean it up a bit. What we're going to delete are these different nodes by just dragging a frame around them and pressing the delete key on our keyboard. Now, this flow remains. Let's go through it. In the purple node is the MQTT node that listens to the MQTT server sniffer messages with the topic sniffer. But since this is the MQTT server of Andreas, we need to change it and point it to the IP address of our own MQTT server. We could add the username password as well if your MQTT server is secured, but I'm not going to do that in this case. Let's activate the debug node here to see whether effectively new messages are coming in from the MQTT server with the topic sniffer. And they do. Now, these messages are being forwarded to the JSON node, and the JSON node converts JSON strings to JSON objects. If we deactivate this debug node and activate this one, you will see what that means. So instead of getting an entire string of MAC addresses, this node converts that list of MAC addresses, that string of MAC addresses, to an array of different objects. And here you see the results. So now the message payload contains an array of different MAC addresses in it. And then that array of MAC addresses that our monitor and that our sensor has spotted is being forwarded to this function node, in which Andreas has created a list of his own known MAC addresses in his house. And in the second part of the code, he's comparing the list of newly entered or recognized MAC addresses with the known MAC addresses in his house. And if there is an unknown MAC address in that new list, that unknown MAC address is being forwarded to the next node. Now, of course, we need to do some personalization and to do some cleaning in this to make sure that this list consists of all the MAC addresses of the devices in our own house instead of Andreas's MAC addresses. Then what Andreas does, does afterwards is he is going to create an HTTP request whenever there is an unknown MAC address that is in that list of new MAC addresses. But we are going to delete these nodes as well because this is not what we want to do. What we want to do is to enable a virtual switch in our Domoticz environment whenever there is an unknown MAC address that has been spotted. Let's first activate that device, and that's a dummy device. And we do this by going to Setup, Hardware in Domoticz, and we're going to add new hardware of the type dummy, give it a name, dummy for example, and we'll add it. And from this new hardware, we can immediately create a new virtual sensor. For example, a known MAC address, we can call it, and we can give it as a type, a sensor type, a switch. We press OK. So this sensor is now created. When we now go to the Setup Devices list, we will see that this dummy device is available in our devices list and it has the ID 106. What we want to do now from Node-red is to prepare a message by using a function node where we are going to send a message to Domoticz to turn device 106 on whenever an unknown MAC address has been recognized. And we do this by this code. So what we're saying is first we're going to make message payload .idx, the message payload ID is going to be 106. It's the ID of our device. The command is switch light and the switch command is on. When we created this message, we just have to offer it to the MQTT server. Of course, to the correct MQTT server, and with as a topic Domoticz /. in. Quality of service, retain is false. So what will happen now? And what does this flow do? From the sniffer, we receive every few seconds, a list of MAC addresses that it has recognized. That list of MAC addresses is a JSON string, which is going to be converted to a JSON object, after which we are going to compare that list with the list of known MAC addresses that we have defined in this function node ourselves. Whenever there's a MAC address that is not in the known list, that MAC address will be forwarded to here, and then in this function node we indicate we want to prepare or we want to change the message to make sure that and add to the message a payload ID 106 and give the command switch light on and forward that to Domoticz with as a topic domoticz/in. When I now click deploy, what happens is that the next time that such a message arrives with an unknown MAC address in it, it's going to be forwarded to the MQTT server. Domoticz picks it up and it should activate the light. You see, and this is what just happened. I can turn that light off again, and the next time that a message comes in, it turns it on again. Now the nice thing is we can create some events based on this, advanced events, to turn other certain lights in our house on or off, or to activate different commands whenever this dummy light, this dummy switch is being turned on. As a last step, we will now configure Domoticz to send a telegram message whenever the switch is turned on. And we do this by going to Setup, More Options, Events. In here, we are going to create a new event, unknown MAC, I'm going to call it. And in there, I'm going to indicate if the light switch is turned on. And for that light switch, I'm going to take the dummy switch we created. Then, what I want to do then is send a notification through subsystem Telegram with a normal priority. And the text I want to use is as a subject unknown MAC address, and the message, the Telegram message itself is there is someone with an unknown MAC address around the house. Up. When I'm now saving it, automatically, whenever the switch is going to be turned on, a Telegram message is going to be sent to my phone indicating that someone is around the house. Instead of waiting for this to happen, I just can simulate this, and you see that a message pops up in my Telegram client. You see? And now it's happening automatically as well. So this is it, and this is how I tied everything together under this simple event. I found this project very exciting and valuable. It gave me the opportunity to get a better understanding of Node-red and MQTT, and I found a use case to work with dummy switches in Domoticz. Also, reusing the code of Andreas Spies made it very easy to get started with Arduino sketches and ESP8266. In practice, I found some shortcomings in this project. It seems, for privacy reasons, that Apple decided to use virtual MAC addresses, so they are no longer a unique identifier of a wireless card. My iPhone is therefore often not recognized as a known device. Also, when receiving visitors, I keep on receiving messages indicating there is an unknown person around my house. I will need to see how I can temporarily mute the notifications for specific MAC addresses. I did find out how to reduce the false positives of my own iPhone by disabling these settings on my phone. This didn't, however, take away the problem entirely, since sometimes it still seems to broadcast a unique MAC address when I pass by the sensor. What I may do in next video is make Domoticz smarter, so it can check whether I'm at home or not before triggering notifications about unknown MAC addresses. But that is for a next video. Thank you very much for watching the fourth episode in this Domoticz series. Don't forget to like, comment and subscribe, and I look forward to sharing my next video with you. Goodbye.